Welcome to Chapter 4 of the National Core Manual. This chapter is about pesticide formulations. The definition of a pesticide formulation is a pesticide product is purchased containing a mixture of one or more active ingredients, carriers, inert ingredients, and or other additives diluted for safety and ease of application. Before we begin talking about different types of pesticide formulations, let's review the difference between active and inert ingredients, referred to as other ingredients on pesticide labels. The active ingredient in a pesticide formulation is the actual chemical in the product that controls the pest. A good way to remember it is the active ingredient performs the pesticidal activity or action. The EPA requires the name or names of the active ingredient to be clearly stated on the label. Some products contain more than one active ingredient. For example, the product label on the slide shows this product contains pyrethrins and pyperenol butoxide. They're all listed on separate lines under active ingredients, and the percentage of each is listed too. The inert or other ingredients are only required to be listed by their percentage. You don't see a list of names under the other ingredients. In some products, the other ingredient could simply be water. Other ingredients don't perform the pesticidal activity, but are still a very important component of the formulation. Many pesticides in their pure or concentrated form are not suitable for application. Some are extremely toxic. Many do not mix well with water. Some are unstable, and some are difficult or unsafe to handle, transport, or store. In many cases, the other ingredients are added to make the formulated product safer, easier to handle and apply, and or more effective in managing the pests. Some simply dilute or carry the product. Pesticides come in various types of formulations. There are liquid formulations, dry formulations, and some very unique formulations that don't quite fit into the liquid or dry formulations categories. Most people are familiar with liquid pesticide formulations, but they probably didn't realize how many different liquids exist. A few examples are emulsifiable concentrates, EC, solutions, S, ultra low volume, ULV, invert emulsions, flowables, F or AF, and aerosols, A. There are several other ways pesticides are formulated and delivered. A few examples are impregnants, insecticide-treated ear tags, pet collars, or pest strips. Animal systemics, external or oral pesticides to control fleas and ticks. How many of you have dogs? Have you ever placed the flea and tick drops on the back of their neck? There are also flea and tick control pills. Both work once the pesticides work their way into your pet's system. When fleas bite the dog, the pesticide starts working on the flea. Fumigant tablets and soil fumigants are both a form of gas. These products are highly toxic, not only for the pesticide handler, but also for anyone else with a certain distance from the site. For this reason, people who will purchase and or use these fumigants need fumigation-specific training and certification. Microencapsulated. There aren't many of these products, so don't worry if you haven't heard of them before. To simplify it, the formulation consists of a small or micro, dry particle or a liquid droplet covered with a plastic or starch coating. They're then mixed with water and applied as a spray. They're designed as a timed, slow-release product. As the coating breaks down, the pesticide inside slowly releases. Because of this, they have a longer REI after the actual application. Pesticide and fertilizer combos. This is a very commonly found formulation. One example you've probably seen is a weed and seed product in gardening stores. The names of some of the dry product formulations that might be available to you are dusts, D, soluble powders, SP or WSP, wettable powders, WP or W, granules, G, water dispersible granules, WDG, or pellets, P or PS. Dry products are interesting because many of them look alike, such as dust and powders, but they perform and are applied differently, which is a perfect lead into our next activity. When you're searching for details about the pesticide's formulation, some labels make it very easy for you by spelling it right out on the front panel. Here's a great example. It's Olympus 70% water dispersible granular herbicide. It doesn't get clearer than that. It's telling you that 70% of the formulation is the active ingredient. It's a water dispersible granular product, and it's an herbicide. Other labels might contain a combination of numbers and acronyms. They still provide you with the formulation details, but you need to know the code. Here we have Belay 50 WDG insecticide. This is telling you that 50% of the product is the active ingredient. Since it's a dry product, it's 50% by weight. Similar to the previous product, it's also a water dispersible granular product, but this label contains the acronym WDG instead of spelling out the words. Lastly, it states that it's an insecticide. I'd like you to become familiar with some of the acronyms you might see on labels. Look at the abbreviations chart on this slide. Each of these refer to different types of pesticide formulations. You might find a product name that doesn't spell the formulation out as clearly as the previous two examples, requiring you to dig a little deeper into the label's directions for use section. Never hesitate to contact the pesticide manufacturer if you have questions about a product. They can provide you with additional information and guidance. Here's a picture of a bait block for rodents. Basically, a bait is a pesticide mixed with food or other substances designed to attract the pest to the pesticide bait. The active ingredient is usually a low percentage. You've probably seen solid baits in a protective box like the one on this slide in an area outside of a resort or other building. They must be placed in an area away from children and pets. The advantages of bait blocks are that they're ready to use, the entire area need not be covered because pest goes to bait, and they control pests that move in and out of the area. The disadvantages are that they might be attractive to and harm children, pets, and non-target wildlife. They require careful placement and inspection. Pests might prefer to eat other plants or food instead of bait. Dead vertebrates might smell if not removed after pesticide stops working, and they might serve as a food source for a pest. Here's a picture of a device used to apply a gel or paste bait. These formulations are used to mainly control ants and cockroaches. They're injected or placed as either a small bead or dot inside cracks and crevices of buildings where insects tend to hide. The advantages of gels, paste, and other injectable baits are that they last for a long time, are odorless, produce no vapors, there's low human toxicity risk, and low applicator exposure risk. Hidden placements minimize human and pet exposure. You can be very accurate in their placement and dosage, and they're easily placed where insects take shelter. The disadvantages are that they can become contaminated from exposure to other pesticides and cleaning products. When exposed to high temperatures, gels can run and drip, and they might stain surfaces or cause buildup after repeated applications. Granular products are dry, thick, heavy particles. They're mostly used to apply products to the soil, where they control weeds, nematodes, or insects, or are absorbed by plant roots. They're also useful to control mosquito larvae and aquatic weeds. Once applied, they slowly release the active ingredient. Some might require to be watered in to initiate the release of the pesticide. The advantages are that there's no mixing required. They're easy and ready to use. There's a low drift hazard and low applicator hazard. You need simple application equipment, and granular products might break down slower than liquids. The disadvantages are that there's a need for frequent calibration. They're measured by weight, and the particles are not uniform in size, which could impact the application. They don't stick to the treated area, and therefore they might need to be incorporated into soil or watered in. The biggest concern and disadvantage is that the granules might look like food and be consumed by wildlife. Most pellet formulations are similar to granular, except they're more uniform in size. They create the uniform pellet by mixing the active ingredient with other materials to form a slurry, a thick liquid mixture, which is then extruded under pressure and cut into specific lengths. You can use them for spot treatments, and a few fumigants are formulated as pellets as well. The advantages are similar to those we just covered for granules, except pellets are more uniform in size and can be applied with precision. There's no mixing, they're easy and ready to use. There's a very low drift hazard and low applicator hazard. Only simple application equipment's required, and they might break down slower than liquids. The disadvantages are also the same for granules. There's no need for frequent calibration. They're measured by weight and the particles are not uniform in size, which could impact the application. They don't stick to the treated area and therefore they might need to be incorporated into soil or watered in. And the biggest concern, once again, is that the granules might look like food and be consumed by wildlife. Most dusts are dry, ready to use products applied directly to the site. They have one or more active ingredients plus a carrier made of talc, chalk, clay, nut hulls, or volcanic ash. The size of the dust particles vary but are usually small. Some of the uses include ornamental and home garden pests, crack and crevice spot treatments of insects and structures, external parasites on livestock, and as tracking powders. Pests walk through the dust, get it on their feet, and then consume the pesticide when they clean their feet. The advantages include that there's no mixing and they're easy and ready to use. Many, but not all, contain less than 10% of the active ingredient. As I just mentioned, some dusts are used as tracking powders and are effective for insect and rodent control. They're also effective in hard to reach areas where a liquid formulation might damage the area. The disadvantages are that there's a drift potential, and dusts don't easily stick to the area. They can irritate your eyes, nose, throat, and skin, and there's a high inhalation risk. Humidity could cause the dust to clump. Dusts are hard in calibration and difficult to evenly distribute. The wettable and soluble powders are dry, finely ground solid materials. They're usually mixed with water and applied as a spray. The difference between the two powders is that soluble powders dissolve easily in water, if you remember from our sinker, floater, true solution demo, whereas wettable powders don't dissolve easily. When mixed with water, they form a suspension and will settle out if you don't have constant agitation in the tank, so you need to make them into a slurry, which you dilute even further after that. The advantages of both formulations are that they're easy to store, transport, and handle. They're not likely to harm treated plants, animals, and surfaces. They're not phytotoxic, and there's a lower risk of skin and eye absorption than liquid formulations. The disadvantages of wettable powders is that they're not easy to measure and they must be weighed. They're not easy to mix. There's an inhalation hazard and they require constant agitation. WPs quickly settle in tank if agitation stops. They might clog nozzles or screens. They're abrasive to pumps, nozzles, cause equipment wear. They're difficult to mix in hard or alkaline water, and the residues might be visible on treated surfaces. As was already mentioned, soluble powders dissolve easily in water, which is a great advantage. However, there are very few of these formulations available because there aren't a lot of dry active ingredients that dissolve easily in water. They don't share many of the disadvantages because they're not abrasive to equipment, but they are easily inhaled. You're probably familiar with water-soluble bags since many laundry and dishwasher soaps are also packaged in water-soluble bags. For pesticide formulations, a precise amount of wettable powder, soluble powder, or gel containing the active ingredient is packaged in a bag that dissolves in water when dropped into the tank. This packaging method reduces the handler's exposure to the pesticide. The bags won't dissolve in organic solvents or emulsifiable concentrates. Notice in the photo the person has pulled a smaller bag from an aluminum pouch. The pouch protects them from humidity, so make sure they're sealed tightly. The advantages are that the bags are accurately pre-measured units, which are safer for the handler due to minimal contact with pesticide. There's also a low risk of spills because you simply drop them in the tank and never open the dissolvable package. The disadvantages are that the package size might not match the amount you need, and if you're applying in pounds or gallons of active ingredient per acre, you might need lots of packets. The packaging is sensitive to moisture and might dissolve if it gets wet before use as well. Now we're going to move on to some of the liquid formulations. We'll start with some of the easier ones to describe, solutions. There are ready-to-use solutions, which are pretty self-explanatory, and there are concentrate solutions, which you might see as water-soluble concentrates, liquid concentrates, or soluble concentrates. These require dilution in a solvent before you use them. The solvent's usually water, but it could also be a refined oil or petroleum-based solvent, which will be indicated on the label. When diluted, these formulations form a true solution. Let's focus on the advantages of the concentrated solutions. They're easy to handle, transport, store, pour, and measure. They require no agitation, are non-abrasive, don't clog screens or nozzles, and leave no visible residue. The disadvantages are that there's limited availability, especially water-based solutions. Spills and splashes are difficult to clean up and decontaminate, and some are easily absorbed through skin. Now let's move on to emulsifiable concentrates. This formulation usually contains an oil-soluble liquid active ingredient, one or more petroleum-based solvents, and a mixing agent. The mixing agent allows the formulation to be mixed with water to form an emulsion. Most ECs have 2 to 6 pounds of active ingredient per gallon. You'll notice there are EC formulations to manage pests in a variety of industries: ag, forestry, ornamental, structural pest control, and food processing. And they all use different types of application equipment. It's a very versatile formulation. The advantages of EC are that they're easy to pour, measure, transport, and store. Little agitation is required when equipment's running, and they won't clog nozzles or screens, and they leave little visible residue. There are quite a few disadvantages. The high concentration of active ingredient makes it easy to over or underdose or result in calibration errors. Hazards include possible phytotoxicity, dermal absorption, and it's difficult to clean up spills. They might have strong odor. Solvents may cause wear and tear on rubber equipment parts, hoses, or gaskets, and possible damage to painted finishes. Also, ECs are flammable. I think this picture really shows the thickness of the flowable formulations, making them easier to describe. The active ingredient is an insoluble liquid that won't dissolve in water or oil. They're prepared by first impregnating the active ingredient into a dry carrier such as clay. Then this is ground into a fine powder. The powder is suspended in a very small amount of liquid. The result is a very thick liquid suspension. Interestingly, in addition to the acronyms F and AF, you might see the acronym L on the label for this formulation, meaning that an insoluble material is presented in liquid form. The advantages are that they're easy to handle. There's a low exposure risk, and they're not phytotoxic. Even though it starts out as a dry product, there's a low chance of clogged nozzles or splashes before it's a thick liquid. The disadvantages are that because it's so thick, you'll also need to shake before measuring or mixing. It might settle in the tank and therefore requires moderate agitation. It might be abrasive to equipment, difficult to rinse the product from the container, and there might be visible residue on the treated surface. Also, spills are harder to clean up. Ultra-low volume, or ULV, is seen in the picture here. The truck's applying a pesticide in a very fine mist, using a high-pressure spray to reach the pest in a tree canopy. Just a side question. What's the potential hazard in this picture? It's drift. Interestingly, ULV formulations can contain almost 100% of the active ingredient. The ultra-low volume name means they're all applied at ultra-low volumes per unit area. They're most suitable for outdoor applications in ag, forestry, ornamental, and mosquito control. The advantages are that they're easy to handle, transport, and store. They require little to no agitation, are not abrasive to equipment, don't plug screens and nozzles, and they leave little visible residue. The disadvantages are that the small droplets lead to a high drift hazard, and you will need very specialized equipment. The fine droplets are easily absorbed through the skin and easily inhaled. The formulation is hard on equipment parts such as rubber, hoses, gaskets, and pumps, and it requires special care during calibration and application due to concentrated form. Aerosols contain one or more active ingredients at a very low percentage and a solvent. The aerosol shown in this picture is a ready-to-use product, but there are others made for use in electric or gasoline-powered aerosol generators that release the product as smoke or fog. The advantages of aerosols, such as this ready-to-use product, is that they're easy to use, are convenient, portable, and easily stored. You can buy and apply small amounts of pesticide, and they retain their potency for some time. The disadvantages are that they're practical for only a few limited or specialized uses. There is the risk of inhalation exposure. They're hazardous if punctured, overheated, or used near an open flame, and it may be difficult to direct material at a single target, although this person didn't have a problem. Consider the formulation when selecting a pesticide product. Ask yourself the following questions to help you decide if the product is appropriate for your site and pest control situation. Is the intended use, site, and pests listed on the label? Do you have the necessary application equipment for that type of formulation? Can the formulation be applied appropriately under the conditions in the application area? Will the formulation reach the intended target and stay in place long enough to control the pest? Is the formulation likely to damage surfaces? And is there a less hazardous formulation that would still be just as effective? Now we'll talk about other substances you might add to your mix, along with their functions. We'll touch on them again when we talk about tank mixing and compatibility during the planning the application session later in this course. Adjuvants are chemicals or agents added to a pesticide mixture to improve the action of a pesticide or change the characteristics of the formulation or mixture. Most pesticide products, especially those that are applied to foliage, contain adjuvants. However, in some situations, such as what we see in the sample label, a label might recommend adding something else to the tank. Interestingly, this label states adding oil, a wetting agent, or other surfactant to the spray might increase effectiveness on weeds, but it also might reduce selectivity to crops, resulting in crop damage. This slide describes some of the types of adjuvants. Anti-foaming agents reduce foaming of spray mixtures. Buffers or pH modifiers allow pesticides to be mixed with dilutants or other pesticides of different acidity or alkalinity. Compatibility agents help when combining pesticides with other pesticides or fertilizers known to be incompatible. Drift control additives reduce drift, increase droplet size, or reduce fine size droplets. Emulsifiers allow petroleum-based products to mix with water. Stickers keep pesticides active on a target for an extended period. And invert emulsifiers allow water-based pesticides to mix with petroleum carriers. Here's 5 more examples of adjuvants and their functions. Plant penetrants allow pesticide to get through the outer surface to the inside of treated foliage. Safeners reduce the toxicity of a pesticide for the handler or the treated surface. Spreaders allow pesticide to form a uniform coating over a treated surface. Thickeners help to reduce drift or slow evaporation. And wetting agents allow wettable powders to mix better with water. There are many different reasons for adding adjuvants to the mix. The bottom left photo shows a pesticide or combination of pesticides that are foaming over the sprayer. An adjuvant, such as a defoaming agent, can reduce this problem. The bottom right picture shows someone adding a blue dye to the tank, an adjuvant often used by people doing right-of-way work and spot treatments to indicate the patches of weeds they've already sprayed. You might have heard the term surfactant. Some of the most common types of adjuvants are surfactants, which alter the dispersing, spreading, and wetting properties of spray droplets. Surfactants are also known as surface active agents, and they're a type of adjuvant. Remember, adjuvant is the umbrella term. As you see in the top photo in this slide, the liquid is beating up on the leaf. Adding a surfactant, such as silicone, allows the pesticide to spread out further on the leaf surface, providing better pesticide coverage. Other types of adjuvants that aren't surfactants include buffers or pH modifiers, compatibility agents, defoaming agents, colorants or dyes, safeners, and thickeners. Surfactants are classified by how they split apart into charged atoms or molecules called ions. A pesticide can behave very differently in the presence of an anionic, non-ionic, and cationic surfactant. Selecting the wrong one can reduce a pesticide's effectiveness and damage treated plants or surfaces. Luckily, the label once again comes through to save the day. Read and follow the label when selecting a surfactant. And now we'll compare the three and review my odd memory tips. They may seem strange, but because of that, you're almost guaranteed to remember them. Anionic means negative charge, most often used with contact pesticides. My odd memory tip is anionic, and I tested negative because I've had no close contact with anyone. Non-ionic means no electrical charge. These are most often used with systemic pesticides, and they help sprays penetrate the cuticle. Another odd memory tip is non-ionic, no electricity in the system. Cationic is a positive charge. Don't use these as standalone surfactants. They're often phytotoxic and they can cause plant damage. Cationic is a positive charge. Cat paws sounds like cat paws. The cat's paws scratched the plant and damaged it. It's important to choose the right adjuvant. Read and follow the label. Test a small amount in a small area. This concept is similar to the jar test because it'll give you an opportunity to see how well it works before you use a larger quantity in your tank or out in the field. Use adjuvants that have been tested and found effective for your use. Use only adjuvants manufactured for your industry, for example, ag or horticulture. Don't substitute the recommended adjuvant with a household detergent. Most importantly, adjuvants are not a substitution for safe application practices. Simply adding a drift retardant won't suddenly give you the green light to apply pesticides on a windy day.